Yeah, can you see my screen?
Yeah,
Good. Today we will go over control flow statements, which involves both conditional and iterative. Then we will discuss functions, and after then we will learn about strings, lists, tuples, and other data structures in depth. I decided to teach these before the actual data types because all my previous classes have been just content, right? I think you are finding it very difficult to write any usable or any executable code. So once we complete the conditional and functions, you can at least write a basic amount of code by your own. Good. Yes. Hmm. The name control flow itself gives it away. What it means is controlling the flow of execution. By default, any line or any code written in Python is written from top to right, right? We generally write code from top to bottom and not from bottom to top. And we automatically assume that any code we write will be executed from top to bottom. Like here, if I write a is equal to 2 and try to print a, we by default know that a is equal to 2 will be executed first and then print a will be executed next. This is what in general we call sequential. Sequential means one after another from top. But what if we want to conditionally execute, let's say we have 10 lines and we only want to execute 2 to 3 lines out of these 10 lines only when a condition is satisfied, and we want to skip it if a condition doesn't satisfy. Condition is nothing but an expression that returns a boolean value. In yesterday's class we went over relational expressions and logical expressions, right? Both of them return a boolean value. When I mean a condition, it is nothing but either a relational or a conditional expression or a mix of both. So control flow statement is all about controlling which lines are executed when, whether we should execute a few lines or we should skip a few lines. The control flow statements can be categorized into three groups. Sequential flow. The default, by default, Python is sequential from top to bottom. You already know this. And conditional flow, whether a few lines should be run or the lines should be skipped. For example, if age is equal to 12, if age is less than 18, print don't allow to movie. See, here age is equal to 12 is self-explanatory. But here, if age is less than 18, this condition, this is what is determining whether this print should execute or not. Let's say when I run it, you should assume that a is equal to 12 should run and also print should run, right? But no, print will only execute when this condition is satisfied. And this if here itself is called a conditional flow statements. The premise is very simple. Conditional statements just determine whether a set of lines should run or not. That's it. And there is a third type of control flow statement. What if we wanted to run a same code block or a same set of lines again and again? Now print hi. Now what if I wanted to execute this line 20 times? Should I write print hi again and again? No, right? This is impossible. This is not 20 lines is physically possible, but sometimes what will happen is we will have a million times and we have to do a same task a million times, and it is physically impossible to copy and paste the same code block again and again for a million times, right? So here comes the repetitive or iterations or looping statements. What they simply do is See, here, whatever is written inside this block or indented, indent is nothing but a tab, four spaces. This will become the actual body. This is the actual code block that we want to run again and again. This line is all about telling Python to run. Please run the below block for 10 times. If we wanted to run the below block for 5 times, we would have written 5 in here. That's it. Let me run it. See, here I am executing the print high, this line 10 times. If I wanted to run 2 times, I would have just written 2. Here is just the basic understanding. Control the flow of execution in Python is categorized into 3 ways. Sequential. By default, everything runs from top to bottom. Conditional, whether we should run a code block or skip the execution of a code block. And third one, iterative or repetition, whether we should run the same code block again and again. Clear, right? Good. Now we will go in depth into conditional and then loops too. Conditional statements and branching. When I explained conditional using the if, you might have already understood that it is like branching a tree. Ignore the word branching for now. You will learn about it later. Python in general provides 3 main types of ways to determine whether a line or a code block should run, execute, how it should be executed. They are if else, if and else. They might sound scary, but they are very simple. We have already used if too. If is written like this. Here we just write the if. If you see on my left, the syntax of how we can use the if looks like this. We should write first the if is a keyword and then write a condition. Condition is nothing but any relational or logical expression that returns a Boolean value. And then you can just write the code or the block that should be executed when this condition is true. On my right side, here is an example. If age is equal to 32 is just a variable. And here I written the if block stating that if the age is less than 18, please execute everything below here. This is what I am instructing Python to do. And this is what it is doing. Is the structure of if clear? Okay, good. Now if else. If else is nothing but an extension of if. Here we just declare that if this condition is true, execute these lines, right? But what if this condition is false? In such situations, if we wanted to don't give me a minute. See here, if the condition is true, execute this. Else, if the condition fails in any other case, please execute this. If is nothing but an else is nothing but an extension of if. Don't allow to movie. Let me change this. If I made the age 122 and try to run it. See here, this condition failed. So, no. Sorry, I printed yellow. Yellow. Good. The syntax of if else looks something like this. If this condition remains true, everything inside the if will get executed. And if the condition becomes false, everything inside the else will get executed. But in some cases, we want very fine-grained control. That means we want to control, we want to execute only a block if the previous one fails. Like in such cases, if else comes into picture. Let me use the same example. Here, if less than 18, we allowed him to didn't allow him to move, right? What if if age is greater than 28? Just give me a minute. Settings. Suggestions. Here. Very hard. See, here I made it very fine grained. If he is less than 18, don't allow. If he is greater than 28, don't allow and print this message. If he falls, if these both conditions fail, then execute this block. See, since his age is 122 and this condition is satisfied, this block is executed and the rest of the blocks are ignored. If we should use if only if we want to determine whether a few lines are executed or not. We should use if else if we want to execute a few lines if the condition is satisfied, and if it doesn't satisfy, the next lines are written in the if else. We want to use if else, if, elif and else only if we are checking whether one condition is satisfied, then we should execute a block. If it doesn't satisfy, we should check the next condition and then the next condition and so on. If we want to check conditions one after another, let's say we have 10 conditions. If condition 1 is true, execute something. If condition 1 is false, check the condition 2 and execute something. If condition 2 is also false, go to condition 3 and check if it is true, execute. Else, go to condition 4 and so on. We should use if, elif and else in such a way. And there is no limit to the number of elifs we can write between if and else. We can theoretically write infinite number of elifs. It will check this. If true, executes this. If false, comes to elif, the second elif. And if true, executes this part. Else, it will go to the next elif and so on. I think you should get the picture. Is if else, if elif and else clear? Is there anyone who doesn't understand what's happening? Good. Yeah, you can basically skip the next remaining portion in this notebook. We will revisit them again once at the end of the course. Now we will go directly. That's it. Inside control flow statements, we have already completed the conditional statements, and now we will complete. We will be learning about looping statements. Record, hide. Now the looping statements. Hmm. As I said earlier, the loops are a part of control flow statements used to execute a code snippet, a Python code, again and again. And here are two cases. Sometimes we know that we need to execute a code block for a fixed number of time. Let's say we want to execute something for 5 times and execute something for 10 times. In some cases, we don't know how many number of times we want to repeat or execute the same block of code again until a condition is satisfied. And thus, there are Python provides two ways: the for loop and the while loop. The for loop is used to execute the for loop can be used when we know that we need to execute a block of code for a fixed number of times, and the while loop can be used to know that when we can only be used when we don't know the number of times we need to execute a block of code. And the syntax of the for loop is very easy. We just write the keyword for, then this looks something weird like this: item in iterable, and then the code block and the block of code that should be repeated is written inside the for, like this. Here it is very confusing. For item in iterable, right? What did I mean by iterable? Iterable is nothing but any data type or data structure that contains smaller data units within it. In our case, iterable is equivalent to a string, can be equivalent to a string, can be equivalent to a list, can be list, tuple, set, or a dictionary. And here the item part is nothing but a variable. Here we give you an example. For student in John. I think this part should be clear, right? I am just creating a variable storing a list containing student names. And now I want to iterate over each and every student. Here I just wrote for student in student. What this means is go over every element in this iterable or in this list, and in each iteration the student variable contains the student. For in the first iteration student contains John, in the second iteration student contains Alice, and in the body I have just written a print statement which will just print the actual name. See here, for item in iterable means go over every item in the iterable, and the item variable holds the one value sequentially from starting to the end. And in the body, you can do anything. You can use this item variable to do something, or you cannot do anything. You can just ignore the variable and do something else. Print hello world. But the length of the iterable controls the number of time the loop executes. See, here I ignored the student variable and just written something else. Here, print hello world. This has nothing to do with the student. But this is only executing for 2 times because the iterable only contains 2 elements. We can even do the same for a string. Here is a syntax. Here is the every possible way a for loop can be used in Python. For I in range n, this is nothing but telling Python to run for I in range. 5. Just telling Python that run whatever is inside the block that many number of times. This is something you should by heart. The range 10 is nothing but is a way of telling Python that you should run 2 times. This and the I is nothing but a variable taking the values. Here I can be anything. Here I just used the variable name as I, right? You can even do ABCD. That ABCD will take the values. ABCD. See, here I am printing ABCD, which took the value 0 first time, and then printed hello world first time, and then the ABCD took 1 for the first time and then printed hello world for the second time. If you see, it only ran for 2 times because we mentioned 2 in here. This is an advanced form of range. We will discuss about it in lists in detail. For I in list, we already completed this. See, here students is a list, and for student in students, here the I is nothing, is a name given to a variable, right? So here we just used the variable called student, and the body will run as many number of times as the number of elements in the list, and I will take the values of each list from starting to the ending. Ignore this, we will learn about this later. Ignore this. No. Yeah, ignore this too. Chip. Yes. We can even do the same thing for a tuple too. If this is a tuple, let's say the only difference between a list and a tuple is brackets, right? See, the same thing will happen. We iterated over list in the same way. We iterated over the tuple in the same way. We can iterate over a string in the same way too. Chars, A, B, C, D. I'm writing some random chars, storing it in a variable called chars. For C in chars, print C. See, here I am iterating over individual character in our string, and I am printing it. This might sound meaningless. Why we should even iterate over a string? Why we should iterate over an list and tuple? Let me give you a practical example. Let's say we have the 10 students, and what we want to do is send an email to each and every student. No, let's make it far more advanced. Uh, Students is equal to Lisa, Bob. Here is a practical situation. There are 3 students, and there are 2 students who paid the fees and one who didn't pay. We stored all the students in students and pending students who didn't pay fees in this list, 2 different lists. Now here all the below code I will be writing will make use of conditional statements, control flow statements, and operators too. Everything we have discussed until now. Now they gave us a task. Go over all the students, identify the students who didn't pay the fee, send an email to those students who didn't pay the fee. In such cases, we couldn't write down the same block of code for Alice, Bob, and Charlie again and again, right? So what we do is we just iterate over the list, student list. This is pretty annoying. For student in students, iterate over every student inside an if student in pending print send an email else print send an email with you paid fee. See, here I just had two lists. One list storing all the student names, and the second list only storing the names of the students who are pending, who didn't pay the fees. And here in our iteration, we are going over each student and checking. If you see, this is an membership expression we have discussed about in the previous class. I am checking whether the student is in the pending list, and if he is pending, I am just writing print statement here, but actually in the future we can even replace this with an function that sends an email to. You didn't pay the fee. I am sending an email to him stating that you didn't pay the fee. Else means if student in pending, right? If the student is not in pending, then even in that case we are sending an email stating that you paid the fee. Let me run this. See, print processing student. To make it easier to understand, I am adding another statement. I am processing the which student is being processed and whether he paid the fee or not. See, processing student Alice, send an email with you paid fee. Processing student Bob, send an email you paid fee. Processing student Charlie, send an email you didn't pay fee. See, this is how the control flow statements, the expressions all fit together to replicate a real world, to model a real world situation and make programming useful. Clear? Is there anyone who didn't understand how the if else and if conditional statements didn't work, or iterative statements doesn't work?
లిస్ట్ స్టూడెంట్స్ అని ఇచ్చారు కదా, మళ్ళీ కింద స్టూడెంట్ అని యూజ్ చేశారు. సో అది ఎలా అంటే స్టూడెంట్స్ అని ఇచ్చాం కాబట్టి అందులో ఉన్న అన్ని స్టూడెంట్స్ అయి ఉంటాయన్న.
which line? ఈ లైనా?
మళ్ళీ కింద స్టూడెంట్ అని యూజ్ చేశాం కదా,
అవును.
సో అది ఆటోమేటిక్ గా అది తీసుకుంటుందా స్టూడెంట్స్ అంటే?
వెయిట్ ఇక్కడ ఇది స్టూడెంట్స్ అని ఉంది, ఇక్కడ స్టూడెంట్ అని ఉంది అని అంతేనా?
అంతే.
ఓకే, మీకు నేమ్ కాన్ఫ్లిక్ట్ అవుతున్నట్టు కనిపిస్తుంది, కానీ ఒక వేరియబుల్ నేమ్ మారుస్తాను ఒక నిమిషం. ఐ అని పెట్టాను అనుకుంటున్నాం కాసేపు. సి అది జస్ట్ వేరియబుల్ అనమాట. అక్కడ ఫర్ కి ముందు ఏం రాస్తామో దానిలోకి డేటా వచ్చింది, దాని పేరు ఏదైనా ఉండొచ్చు.
ఓకే, అదే డౌట్.
యా, వేరియబుల్ అంటే మీనింగే అది కదా. ఓకే, గుడ్. సి ఇక్కడ ఏం చేశాను, స్టూడెంట్స్ అని ఒక లిస్ట్ ఉంది, పెండింగ్ అని ఒక లిస్ట్ ఉంది. ఫర్ ఐ ఇన్ స్టూడెంట్స్ అన్నాను. దీని మీనింగ్ ఏంటంటే ఆ ఇటరబుల్లో 100 ఎలిమెంట్స్ ఉండనండి. ఫస్ట్ ఐలో ఫస్ట్ ఎలిమెంట్ ఇవ్వు, ఈ బ్లాక్ ఎగ్జిక్యూట్ చేయి, తర్వాత నెక్స్ట్ ఎలిమెంట్ ఐకి ఇవ్వు, తర్వాత దాంతో ఈ బ్లాక్ ఎగ్జిక్యూట్ చేయి. అట్లాగా ఇటరబుల్ అంటే మనకి ఏమేమి వస్తాయి అంటే ఎవ్రీ డేటా టైప్ ఆర్ డేటా స్ట్రక్చర్ దట్ కంటైన్స్ స్మాలర్ యూనిట్స్ ఇన్సైడ్. స్ట్రింగ్ని కూడా బ్రేక్ డౌన్ చేయొచ్చు, రైట్? స్ట్రింగ్ ఆఫ్ క్యారెక్టర్స్ కదా, స్ట్రింగ్లో క్యారెక్టర్లు ఉంటాయి, లిస్ట్లో ఎలిమెంట్స్ ఉంటాయి, టపుల్లో కూడా ఎలిమెంట్స్ ఉంటాయి, డిక్షనరీలో కూడా కీ వాల్యూ పేర్స్ ఉంటాయి, సెట్స్లో కూడా ఎలిమెంట్స్ ఉంటాయి. సో ఈ ఫార్మాట్ అనేది యూనివర్సల్ ఫర్ ఐ ఇన్ ఇటరబుల్. ఇక్కడ ఈ స్టూడెంట్స్లో లిస్ట్ ఉండొచ్చు, టపుల్ ఉండొచ్చు, డిక్షనరీ ఉండొచ్చు, సెట్ ఉండొచ్చు. ఇక్కడ రాసేది మాత్రం ఎనీథింగ్, ఇక్కడ ఏమన్నా రాయొచ్చు, అది వేరియబుల్ అవుతుంది అనమాట. ఆ వేరియబుల్లో ఒక పాస్లో ఫస్ట్ వాల్యూ ఉంటుంది, నెక్స్ట్ పాస్లో నెక్స్ట్ వాల్యూ ఉంటుంది. అట్లా ఇక్కడ రాసిన వేరియబుల్ని మనం యూస్ చేస్తామా యూస్ చేయమా అనేది కూడా పైథాన్ పట్టించుకోదనమాట. ఇప్పుడు ఐని ఇక్కడ వాడాను, ఐలో స్టూడెంట్ నేమ్ ఉంటుంది, సో ఐ యూస్డ్ ఇట్ ఇన్ హియర్. బట్ సమ్ కేసెస్ అయి ఉంటుంది, కానీ నేను వాడను అనమాట. నాకు అవసరం లేదు. ఎట్లా ఇక్కడ కొన్ని కేసెస్ ఉంటాయి, అందులో డేటా ఇటరేట్ చేస్తాం లిస్ట్ మీద, కానీ ఆ లిస్టులో ఉన్న ఎలిమెంట్లను మనం పట్టించుకోం, ఇగ్నోర్ చేస్తాం. అండ్ ఇన్ హియర్ ఇంకొక అడ్వాన్స్డ్ ఏంటి అంటే, ఇది కొంచెం ఇబ్బందిగా ఉంటుంది, అర్థమవుతుంది కానీ. ఐఎమ్ రివర్టింగ్ ఐ బ్యాక్ టు స్టూడెంట్. See here, the I is storing the actual value, right? What if I wanted to know the index, the position of the value, and also the actual the position of the value too? Like if I- now I let's say I am processing Bob and I need to know that the index of the Bob too. This doesn't make sense now, but it is useful in later cases. In such case, what we need to do is just wrap enumerate around the iterable. Enumerate is a function, built-in function. We just need to wrap enumerate around the function, around the iterable name. And here we just give one more variable to I comma student. Here the first one will hold the index and the next one will hold the actual data. Let me print processing student I comma student. See, here I am processing student 0, Alice, whose name is Alice. And he paid the fee, so I am sending him an email with paid fees. Processing student Bob, here his position is 1. Processing student 2, Charlie. If you see, then indexing is starting, or the numbers are starting from 0, because Python will start counting from 0 and not 1. This is something we need to get used to. Is enumerate clear? All we have to do is wrap enumerate around the iterable and write one more variable in here. The first variable will hold the actual index or position of the value we are iterating on, and the next variable will hold the data we are iterating upon. Clear? And there are so many other ways of using for, but here I have shown how to zip and set, but you can ignore this. Just go through this notebook and try to read the basic forms of for, because in every data type we will again discuss about how for loop and while loop. Good. Now the while loop. Here the for loop is used when we know that we have to execute a block of code some 5 times or 10 times, or we want to execute a block of code over an iterable fixed, right? If we know fixed number of times, the loop will only execute until the all the elements in an iterable are exhausted, or all the elements in a given range, that is the limit we gave, is completed. But in case of a while loop, it will keep on executing as long as a condition remains true. As I told earlier, condition is nothing but an relational or a logical expression that returns a Boolean value. Let me write while true, print hello. You should never execute this code, because what I am telling is, as long as this is true, keep on executing this block of code, right? See, this will execute until infinity. See, because nothing else is stopping it. Oh, wait. Yes. Stop. See, even though I know that it will go to infinity, I panicked, right? Because I know that as long as the condition is true, this will keep on executing. Then, so we should be careful with the while loops. Let's say I is equal to 0, while I is greater than 5, I is less than 5, print I. Escape. Yes, this makes sense now. Here I just stored zero, the value zero in the variable called I, and here the condition is nothing but check whether I is less than 5. If this is true, execute whatever is inside me. This is what Python understands. Now, even this will go to infinity if I execute it, because let's say I is equal to 0 and 0 is less than 5, right? So it will print 0. Then it will come back again and check whether the value, what is the value of I, which is still 0. So 0 is less than 5. It will print I again and it will still go to infinity. What you might ask, how should I break this? How is this even useful? See, if I do this, I is equal to 0 the first time, I is less than 5. When the while checks the condition, it checks that it is true, so I will execute print I. Then after print, I am incrementing I. I is nothing but 0 plus 1. I is 1. Now the next time when the while checks the condition, it becomes 1 less than 5. And it keeps on doing this until the I reaches the value 4. 4 plus 1 is 5 and 5 is less than 5, not right, 5 is equal to 4. So the condition fails and it will stop executing the block and it will go to the next line. Print while ended. Print while started. Let me execute this. It will all see it started, this line got executed, then it entered the while loop, it checked the condition for 0, 1, 2, 3, 4, and when the value of I reached 5, the condition failed and the loop exited. And the final statement, print while ended, got executed. While is pretty hard to digest at first. Just know that while takes a condition, and as long as this condition remains true, it will keep on executing the body. And you should write the body in such a way that the condition should eventually fail. If you don't, if your body doesn't make the condition failed after a set number of times, while will execute to infinity. In this case, the body, there is nothing in the body that will affect the condition, right? So it kept on executing up to infinity. Even in here, if I remove this line, the body is not making the condition fail. So even then, in such case, it will go to infinity. But by placing this line, I made sure that while will only execute until this condition fails, and I am incrementing I because of that. You can basically ignore while because just know that it until the condition is true, it will keep on executing. If the condition fails, it will break, the loop ends and the flow will go to the next statement. And be careful while using the for, because if the condition is always true, it will keep on executing to infinity and it will burn our database too. Clear? Is the while and for loop and while loop clear? Do you want me to explain any further? Good. Finally, functions. Functions are the easiest part to explain, since we have already gone through everything there: data types, expressions, conditions, and loops. Function is nothing but a block of code that takes in something, processes it, and gives us back the results. As simple as that. And the how we define this is how a function is defined. It looks something like this. The diff is just to inform the def. This is a keyword. This is just to inform Python that everything that I am going to write after the def is going to be the name of the function, and we should open circle brackets and mention few variable names here. Parameter 1, comma pi. These are just generic names. You can give any name. Now the body, and the body contains what you want. If you have these variables, what do you want to do with this data? The body basically represent our expressions, transformation, condition, and loops, and so on. And the return value is nothing but what we want to return. After processing the data given to a function, what should it return? Should it return a single value, or should it return two values or multiple values, and so on? Here, okay, I think I didn't explain this. Comments are written in Python with hashes. Anything written after a hash is ignored by the Python runtime. So here I'm just using comments to explain what happens. Here I can either return a value 1, or either return a value, two values, or return multiple values, something like this. There is no, when you are returning multiple values, you can wrap them around parentheses like this, or you can ignore the parentheses too. There is no difference between this and this. If you want, if you wrap a parenthesis, it is more easy to understand. Okay. Uh, Let me write down a simple function that calculate. Okay, let's do this. Write a function, accept username, math, physics, and chem marks, calculate average, and if average is less than 30, return failed, else return passed. I think you must understand this, right? What I just gave a problem statement. Is the problem statement clear, or did anyone fail to understand this? Okay, assuming it is clear. We basically want a function that will take the name of the user and his math marks, physics marks, and chem marks, calculate his average, and if the average is less than a given value, we will mark this user as failed, else we will mark him as passed. Now this is how it is written. Def, to symbolize that I am starting to write a new function, the name of a function. You can pick any name, but the function name should follow the same rules as a variable name. A variable, if you remember, the variable can only contain small a to z, capital A to z, 0 to 9, and can only start with an alphabet or underscore, right? But the names should be meaningful. Like I cannot write, this function is basically used to determine whether a student is passed or failed, right? So if I named it no, check marks. If I just named it average, this doesn't represent the entire functionality. It is ambiguous, right? So I should write the name. The names of functions should be meaningful. Pass state, not pass status. If I write something like this is more meaningful. Pass status, and we wanted to accept different types of data, right? The different types of data that the function needs to take as input are written here. Here you can write anything, but even the names should be meaningful. Here I need to accept the name of the user, the math marks, the physics marks, and chem marks. So in total, I should accept four different values. So I should write four variables in here. When variables written here in the written in the function definition are sometimes called parameters or arguments. So I should write four parameters in here. But see, I can even write A comma B comma C comma D, and A accept the username, B accept the math mark, C accept chem mark, and D for the physics mark. But it is not meaningful for anyone who wants to use this function. They will get confused. What is A, B, and C? So even the parameter name should make sense. User name, comma, now math marks, right? Math, now physics, and then chem. Here, if you see, I have determined an appropriate name, gave the name to a function to represent what it is going to do. Then determined what are the inputs. It takes four inputs, right? And I have written the parameter names, the correct names, or the names that represent clear meaning. after one after another using comma, and I should put a colon. Colon symbolizes that I am starting out this function body, and the function body should start with an indent, 4 spaces. Let's say print. Here, this print is not inside the function. This is outside the function. So if you want to make something as the inside the body of a function, we need to give a tab indent. Okay, now print. I will just try to print his name. Processing user, comma. I will print the name of the user who called the function, and then the average. I am just using an variable called average and calculating his math plus physics plus chem by 3. See, this is just a pure arithmetic expression. I am adding all three of them together and then dividing them by 3 to find the average. And now here is the decision making part. As I told earlier, conditional statements are used to execute blocks of code based on a condition, right? What our need is, if the average is less than 30, we should return failed, and if the average is greater than 30, we should return pass, right? If the average is greater than, what did I write above? 30, right? Return passed, else return failed. See, here we created the function, but we haven't called it yet. Now let me call. Calling a function is also sometimes called function invocation. We just use the name of the function and then pass it some data. Pass status. Now let me say the name of the student is John, and I am writing down random marks. The function will return something, right? We can use it directly in our another expression, or we can capture it in another variable too. Student, I am creating a variable called student status and storing the results of the function in that variable. Since we want to view what's inside the student status, I am printing it too. See, here when this line got executed, this function started executing, and it executed processing username, then calculated the average and used this if and else block to determine what to return, and it returned pass. The good thing about a function is it will abstract away the complex part. You can write a function and some other people can use the function without knowing what's inside it. And we can call the function again and again. Now, here command C, command V, command V. Here now let's say we have an student called Alice, and with a different thing. Here, without needing to copy paste the same code block again and again, once I define a function with that code block, as long as I change the arguments or the parameters or the data that I pass to the function, I can reuse it any number of times. Is this clear? Or is there someone who failed to grasp what I just told? Good. Now, see, when I tried to call the function, I just mentioned the names, right? The data, I just wrote the data one after another, but I didn't mention that Alice should go into the name, Alice should go into the username, or this number should go into the math, or this number should go into the physics, and so on. But how did Python know which data to pass into which parameter? Because this is what we called positional arguments. When you don't mention the where this data should go, the Python will automatically match them by the position. The first argument will go into the first parameter, or the first data will go into the first parameter, the second will go into the second, and the third will go into the third. But if you mention the name, you can even mention the name here. Username, math, physics. Here I'm just writing down in multiple lines for convenience. You can even you can do this. Okay. See here, rather than just leaving the Python to figure out which variable to match with which data to match with which parameter, I'm just mentioning that username is alias math marks is equal to this, physics marks is equal to this. There is an advantage to mentioning the name of the parameter that this data goes into. Sorry, this process of mentioning which parameter will the data go into is called keyword arguments. But if you just let the Python determine, it is called positional argument. This is an example of passing arguments or passing data to the function positionally based on position. And this is an example of passing data into a function based on the keys or the parameter names. There is an advantage between this and this. The second one is more because we can jumble the order. We can let me control X. See here, I changed the order of the data, but Python will figure it out because I mentioned that the physics marks is 33. Even if the order is jumbled up, the Python will handle it. Make sure that you don't mix the positional and keyword arguments. Like you shouldn't do this. You can technically do this, but since you are a beginner, don't do this. Let me copy this. Control A. Here, you should never do this. This is very dangerous because you won't know which argument is going into which data is going into which parameter. I have clearly written what will happen when you do this, but don't try to use this. Either use purely positional or purely keyword. Good. Now the default arguments. See, there will be some cases when the user may not pass the. If the user doesn't pass the data, we have to accept, we have to default to a value like, let's say, pass mark. Pass mark is equal to 40. Here, what I mean is if the user, the one who is calling the function does not mention the pass mark, automatically take that value as 40. Here, let me use the pass mark here. See, here I am executing this block and calling this function. Here, if you see the function takes 5 parameters as it needs 5 inputs, but here I am only passing the 4. So what Python does is it will map the first 4 with the first 4 parameters, and since the final parameter is an default argument, it will automatically default to the value 40 and it will not raise an error. But if this were a regular argument and I tried to call the function only with if it needs 5, but I am only calling it with 4. See, it raises an error that you didn't pass in all the arguments are mismatched. Default arguments are just a way to pass in the default way, to take default data if the one who is calling the function doesn't provide any. Let me execute this. 1, 2. Good. Okay. So there's no physics mark in here. I think the positional arguments, the keyword arguments, and the default parameters should be clear, right? Good. Ignore the arbitrary positional and arbitrary keyword arguments. We will go over this later if we have some time. And in the notebook, I have clearly written what is what. If you are interested, you can go over the entire notebook. And if you find something difficult, you can just ignore it. With that, in this class, what we completed was we completed the control flow statements. Inside that, sequential flow, conditional flow, and loops. We looked over conditional statements and loops in detail. Conditional basically involves if else, if else, and loops just contain for loop and a while loop. For loop should be used when we know for a fixed that we need to execute a block of code for a fixed number of times, or when we want to iterate over all the elements of an iterable like string, list, tuple, dictionary, and set. While loop should only be used and should be carefully used and only be used when we want to execute a block of code for an until a condition is true, and when the condition becomes false, it should stop executing. And then we went over function. Function is nothing but a block of Python code that receives some variables as input, works on those values, and returns back an output. Yes, here I didn't show the how multiple values are returned, right? Passed here. Let me return passed and also the average I calculated. Here I am returning two values. The status and the pass or not. In such case, we should also take two variables. Since we are returning two values in the function, we should write down two variables to accept those values. Average marks like this. Student status comma average marks is equal to pass status. And the pass status function will return a two values. So I had two variables in here. Let me execute it. Let me execute, write both of them. Student status and average marks. See, if you fail to know, if you don't know the number of values that the function returns, you can even capture it in a single variable like this. In that case, the student status will contain all the inputs, all the return values by the function as a tuple. See, since the function is returning multiple values and I only captured it in a single variable, that variable become a tuple of those values, passed and 1938.0. Good. Go over the all three notebooks, the conditional statements one, the looping, and then the functional functions. And here is a small okay, we exceeded the time, right? Yeah. I will just paste a small practice question in the WhatsApp group. I want you to implement that portion, and by tomorrow, this will just give you an idea or help you understand, solidify everything you have learned using data types, expressions, conditional statements, loops, and functions too. Are there any notes related to today's or yesterday's class?
Tarun, I have one doubt. So, for loop, if you want to break the iteration,
Exactly.
can we use that break in the for loop?
Yes. I didn't explain break and continue for a reason.
Okay.
Since we will go over this again in our data structures, but since you asked, I will tell, I will explain all this. The names break and continue can all they are keywords. I mean, you cannot use them as variables, then they have a meaning to them. They can only be used within loops, either a for loop or a while loop. The word break is self-explanatory. If a condition, let me write this. Do I have no one? Okay. The word break and continue for I in range 10. This is a loop instructing Python to run 10 times for I in range 10. And let's say you want to print I, but only until I is equal to 5. If I is equal to 5, you want to break, because you just imagine that you don't like the number 5. And if the I is equal to 5, you want to stop iterating. That means you don't want to go to the next iteration. All we have to do is, if I is equal to 5, break. The moment a loop sees the word break, it will stop everything. It will not even complete the current execution and even complete the current execution or go to the next execution. It will stop everything and break out. Ideally, this loop should run 10 times, right? Since I wrote 10 over there. But since I wrote a condition here, just if I is equal to 5, that means it will run until 5. But when the I is equal to 5, what it will do is, it encountered a break statement. So it will not go any further. Print. Let me write a print statement to print. I am breaking the loop. See? The moment the I became 5, this condition, this control flow conditional statement became true, and it branched into the print. This print got executed, and inside the if block, it saw a break, so it broke it. It won't go any further. Even if you have, let's say, print I think this makes more sense than this. First, I am checking whether it is 5. If it is not, if it is 5, I am breaking. If it is not 5, I am printing. See, here it didn't even print 5, because when I became 5, it broke, and this print didn't get executed. Didn't execute. Now the same thing can be done in while loop too. Actually, break is a must in whiles, because as I told you earlier, whiles are prone to infinite loops, because if the condition becomes true, it will keep on executing until infinity, right? Print I. I is equal to 0. I is equal to I plus 1. If you see here, I wrote true, which means I am instructing the while loop to run for eternity. This will run as long as the condition remains true, right? But here the condition itself is true, permanently true. I started with I is equal to 0. I am printing I and incrementing I became 1. And if the I becomes equal to 5, only break this loop when I becomes equal to 5. See? But if I remove this, there is nothing stopping the loop. It will go for infinity. I don't want to run this. See, this will never stop. Here we are using the break to break out of the loop instead of the actual condition. See, in this way, we can use the break to either preemptively exit out of the loop in case of for or while. But continue is a bit different. When the loop encounters continue in its body, it will not, it will only skip the next portion in the body. I mean, see, theoretically, what should happen here is, when I is equal to 5, it sees a continue. If I is not equal to 5, it will print I, right? Let me execute this. Here you see 0, 1, 2, 3, 4, but no 5, because when I was 5, this became true and it saw continue. Since it saw continue, it will ignore everything that is below the after the continue. So everything below here is ignored. It is not executed, and the iteration goes to and the loop goes to the next iteration. The next after 5 is 6, right? 10. I wrote 10 here. If you count them, it only executed for 9 times. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I is equal to 5, stopped the print of the value 5. So it went to the 6 directly and ignored the print 5. Is this thing clear? The print and continue? Sorry, break and continue.
Yes, clear.
Yeah. Are there any other doubts regarding conditional statements and loops and functions? Okay, I am assuming everyone is okay with conditions and loops, right? From tomorrow, okay, no, I wanted to give an assignment. Yeah, I will post the assignment. I will just write down the problem statement in the group. All you have to do is I don't care how you write the code. You just don't use ChatGPT. You can either use a web or you can even refer to the notes. I want you to come up with a executable code that will run and solves my problem. That's it. Clear? Good. I will post the assignment in the group. Thank you. That's it for today.